Class, how are you today?
We are fine, and how are you?
Good. Lovely day. Okay, as we yesterday we were talking about those levers, classes of a levers, the parts that are found on a lever. So what have you found at home? What did you recap at home? Because I've asked you nicely that you should recap on your notes at home. And then also I've given you a class homework yesterday. Bringing my books. Where are my books? Where are my books? I want to mark it now. So that I could see that you've been doing it a lot. Okay. Lever is a okay. Good one. Max. Okay. Load, Parker, and then effort. Okay. Max. Classes of a lever, first class lever, second class lever, third class lever, but there is no fourth class lever. Unfortunately, you've been writing fourth class lever out beside this one. Z3, there's a first class lever, second class lever, and then the third class lever, not first class lever. Okay, right corrections of a definition. A definition, I want the definition of a lever to be I will give you this one. Yeah, that one is good, but not in this grade, unfortunately. So okay, what is a lever? Okay, good. Then load fulcrum, good. To max. Then it's not one lever, two lever. It's first class lever, second class lever, third class lever. Whenever you write one class lever, what is that? Two class lever. Just write first, second, third class lever, class lever. Okay, I'll give you. I'll write a correction so that you will write it. Let me sign it. Okay. So today, my students, okay, the definition that I want of a lever, I'll explain it to you. Okay, I want this definition of a lever. Write it down as a correction, please. Write it down as a correction. I won't use a chalkboard today. I'll just illustrate in my note. A lever is a bar that pivots around a fixed point called a fulcrum. What is a lever? A lever is a bar that pivots around a fixed point called fulcrum. So write this definition as a correction. I want it on the test. Everything, even if I ask what is a lever, you should give me this definition of a lever, not just any other definition. Okay, so the second question that I would like to ask now: what did you find based on fulcrum, load, and effort? What is a load? Let's start with that. What is a load? Is there anyone who found or who focused on this question? What is a load?
A load is an output of lever that is moved.
Okay. Thank you. A load is an output. Of a lever that is moved. You see, is that part where you see the output, where you see an outcome. If you are using a scissor, that part, that cutting, it is an outcome, it is an output. It is where you see what? An outcome or an output. So which is why they're saying load is an output. That output, it gives you a clear image that no, it is a part that gives a result. I could say like that in more easier words. Yeah, it is a part that gives what? A result, or that shows a result. Well, when you are using a scissor, you see that your scissor is cutting. Where there is a cutting, where there is a crack, that's where the load is. What is a fulcrum? A fulcrum is a fixed point or a movable connection in a lever or leakage that allows to be transferred where it is needed. Write it down, my student. Then what is an effort? Effort is the input that starts or moves a lever. It is where the man is applying the power. Where the man is applying what? a power. For example, that man with the wooden bar and then the stone. Yeah, when the man is applying his power, it's called what? An effort. So what are the functions of a lever? Write them down, my students. I will ask them. Yeah, maybe in a test or in a class we can ask them. Write that down. Know them. You see, know them, understand them, the functions of a lever. You should write them down. Those are the functions of a lever. So I want you to answer those questions just to check how much you understand about this or what I've done so far. Where do we often use levers? Or where do you often use levers in your home? Just take this question in your home. Where do you often use a lever? Or which object? That is a good example of a lever. What do we get as an output of a lever that is being moved? I've just explained this one. What is a fulcrum? Name 3 functions of a lever. So I want you to answer those questions in your classwork books. Yeah, that's in your classwork books. I'll mark it tomorrow. And as we know that there are classes of a lever, there's a first class lever. Those are the notes. I'm giving you those notes just to write them down. The first class lever. This is the most basic type of a lever. The first class lever. It is the first one, which is the most basic type of a lever. So I'll be writing those notes and then copy them down on your notebook so that you'll be able to read them when you got it home. And then there's in the first class lever, you see that there is a load. There's a load. Just take a seesaw, a seesaw, where the other one will be applying a load, will be applying an effort, applying a load, and then there's this part where that acts as a fulcrum, and then there's what I call a second class lever. In this lever, the fulcrum is at one and the force is applied at the other side of the situation. So for example, you can see a wheelbarrow and then a stapler. Those are the good examples of a second class lever. And then there is a third class lever. A third class lever is a third class lever has the example found on a third class lever is a fishing rod, where you are fishing, and then there's that that's some sort of a thing that goes down on the sea, and then you will be taking out your fish. And then as you can see, that is an example of a third class lever, that diagram there. And then so now I want to show you, or to show you how to calculate mechanical advantage. What is the formula of a mechanical advantage? As you know, mechanical advantage is equal to load over effort, which means it is equal to the output divided by the input to get what? A mechanical advantage. So that is the formula of a mechanical advantage. So the definition of a mechanical advantage, I will write it on the board. That is a formula of mechanical advantage, which is a mechanical advantage is a measure of the ratio of the output either force. So I'll write it on the board so that you'll be able to read it when you're at home. So maybe if you are given 40 newtons that acts as a load, and then divided by maybe 20 newton that act as a effort, then by pressing that on the calculator, you will get a mechanical advantage. So guys, today